So I'm going to continue with the previous video. So I had stopped over here. So I had to build a hyperparameter optimization using Grid Search CV. So Grid Search CV acts as a model selection package. Here first we will import time because so while running this code it will take some time. So let me take import time and also let me import time. So now slow, let me take start time. Start is equal to time dot time and so I'll write the code here. So first we have to uh, build a parameter distribution. Okay. So parameter distribution we have to build. So what I will do is that for all the parameters, I will pass a list of values and then I will pass those values inside grid search CV algorithm. So first, let me build a parameter distribution. Param dist is equal to, so it will be in a key value pair. So first, let me take max depth. So max depth can be something like 2 comma 3 comma 4 comma 5. So this is going to select from the values that you have passed in list. Okay. So we have what we are using grid search CV is that so when you pass this parameter distribution under grid search CV, it will try to find the best parameters from the given set of parameters. Okay. So now we will pass bootstrap as well. We have passed max step can be anywhere 2, 3, 4, 5 we have passed. So it will try to give the best value for the best max step value and bootstrap can be true or false. Okay. So let me tell you about this bootstrap being true or false first. So bootstrap fall means the whole data is used for building your decision trees. Okay. So when you are building decision tree one, decision tree two, decision tree three, decision tree four, it will use whole data because you have a very less number of data without records. So it will when bootstrap is equal to false, whole data is used to build each tree. Okay. If your data is very so you can make bootstrap is equal to false in that case. So whereas bootstrap is equal to true means it will select bootstrap sampling with replacement. Okay, so it will do the sampling with replacement from the population data. It will take samples, and from that sample, it will build decision tree. And then after that, the next decision tree will be created by probably also after doing the sampling with replacement. Okay, this is how it does. So bootstrap is true. If you have enough data for each building each decision tree, then you can go with bootstrap is equal to true, or you can go bootstrap is equal to false if you don't have enough data for the decision tree. Okay, I mean sample you don't have enough, then bootstrap to for the whole data will be used for your building of each decision. Now, next we have max features. Okay, so max features, value can be auto square, so it should be in a bracket auto square root comma logged base 2 comma none. So what does auto does? Auto is used same as square root, so it will take the total number of features. Let's say you have 10 features, so total number of features that is considered for building of your model is taken as auto is equal to square root of n. Okay? Auto and square root same. Auto is nothing but it will do the square root of features you have. And log to the base 2 is it will take log n features. N log n to the base that you're having. And then means it will use all the features that are present in your data set. Okay? The model will use all the features. Let me repeat once again. So when your model is looking for the best plate, maximum number of features to be considered at the point of time is calculated. Auto and square root are same. Log to the base 2 of n is the one. And means it is talking of taking all the. Okay. So now after this, we have to pass the fitting criteria. So we have already seen criterion in decision tree. So we have two types of criterion, actually three, but let's say we have two. So we are passing Gini and entropy. This is mostly used, Gini or entropy. So once this is done, so let's do some one thing. Let's come back out of the loop. So now we will uh, use the grid search CVL, grid search CV off. So now what we will do is see the parameters that are present over here. So don't worry about these things. So let's think about the random forest first. Okay, so you have to pass the random forest inside the grid search CV. So we will pass the random forest with underscore random forest, comma, then we will pass the cross validation. So cross validation I have to already told. So CV is a criterion. So cross CV is cross validation. So we are taking cross validation is in here. So means we will have 10 folds. I have already told you when we are doing cross validation. We'll have k minus one data set is used for training and one data set is used for testing, and it makes sure that all the data are used. So let me show the theoretical part again for your reference. So what happens is that K-fold cross-validation is divide the data set into K groups. Take one group as training set, testing set, and remaining K minus one group as training set. Fit on the training set and evaluate for the testing set. Repeat till all the K minus one groups used as a test set and trace set about evaluation matrix. Based on that, we will do the function. Okay. So now we'll take for grid set CV, we'll take with random forest algorithm cross validation we have. Next, we have to pass the third parameter, that is, so let's look at this here, okay? So we will pass param grid, okay? You have seen this param grid, right? So param grid is nothing but, let's see, dictionary or list of dictionaries. So this is the param grid, okay? Instead of passing these values over here inside this search CV, we have made it easy to look and a very efficient coding way. You have to we have used in a form where we have declared it outside our grid search CV, and now we will pass param grid. Grid is equal to param dist is equal to, so okay, so let me select once again param grid, okay, pass param grid is equal to param dist, okay. So we have our this thing, so grid search CV we have. So we have our param distance distribution. So now we have to pass number of jobs that we run. So we will use total three processes for our jobs. Number of jobs to run is three we will pass. So declare this to another variable, that is cross validation random. Once this is done, now we will fit this to our training set. Okay, cv underscore random forest dot of. So we'll fit it on our training set. So what's the training set we have? Training set we will pass. So training class set is training set, so, comma. So training set, comma, we have class set. So our model is built using that. So we will evaluate the model based on this. So we have passed the training data set, and now what we will do is let's print the best parameters. Okay, CV underscore random forest. So based on the data that we have, so the grid search CV will select the best parameters from the given set of parameters. Okay. So for that we have a function called CV underscore random forest. We have to pass dot best param. Okay. We have best params. So so VESC, okay, best params. And after that, so let's do the stop time as well. So end time is equal to start. We have time dot time. So time dot time end time. So print start minus end. Sorry, this is end minus start, right? End minus start. So this will give you the time it took to run this code. Okay. So let me run all the code for moving so that we'll make sure that it's fine. So okay. So now I will run this code. So let me tell you other points that are present here. So I have already told you about cross validation. So means how many fold of cross validation we are keeping. Here we are taking it as 10. Number of jobs 3 means 3 processor will assign. If we have pass here minus 1, all the processor will be used. Okay. So let me run this. So this will take some time for running this code. So wait for some time. So we have got our more parameters. So best parameters from the given set of parameters that a user has passed. So we have tuned our model in such a way that so which values will give higher accuracy for our training and testing training set we have you find or found out. So when we have passed the training set and class set, that is our extrain and y train for the data set that we have passed. So we have passed the parameters. From these parameters, we had to choose the best set of parameter values. Okay. So we have got bootstrap is equal to true. That means you have to do sampling with replacements. And next we have criterion is Gini. So it has told that to use Gini as a criterion. Then next depth is 5. It has preferred, and max feature is auto, means square root of number of features that we have in our class training set. Okay. So we have a so what we have to do is that, so we have our model, right? So our random forest model we have. So pass that values, the with random forest. So dot, what you have to do is set params. Okay, you have to set the parameters for your model now. So and what are the parameters you are passing over here? So so these are the set of parameters we have to pass inside our model. So bootstrap is true. And criterion is Gini, max depth is 5, and max feature is auto. So now let's revise this code. So it's saying invalid syntax. What's the problem? Let me check first. So this should be equal to, okay? Bootstrap is equal to to entropy is equal to G. Criteria is equal to max depth is equal to 5. Max number of features is auto. So this should be variable, right? So we have to pass it in form of variable. Sorry for the mistake. So now it will be fine. So, so the set of parameters that we got for Bootstrap criteria, max depth, max features, you can see from the grid search CV. Grid search CV acts as a model selection package. So we have got the best parameters parameter values. Now let's run this code. I hope this works. Okay, so we have our model random forest classifier now. Now what we will do is that, so we will use that. So let's take our model that we built with random forest is our model or algorithm. So let's set parameters, set params we are doing here. And what we are doing is that we are passing warm state is equal to true. Okay? Warm state. So let me pass like warm state is equal to true. You know what warm state is equal to true means? If you have any particular parameters, like here we have set of parameters we have passed before, you can reuse those previous value. Then you can add more estimators to this. Okay, more estimators you can add to this random forest. Estimators is nothing but number of decision tree. So how many decision tree you want, so you will get the high accurate results. So what we are doing is that we are setting parameters for a random forest algorithm, and warm state is equal to true. We are making sure that we are using the previous value, and then we add more estimators to that. So when you pass random warm state is equal to 4, then it is going to build all new tree together. Okay, if the new tree all together it will build, and also along with random forest warm state is equal to 0. We want OOB score, out of back score as well. So making out of back score is equal to true. Okay? So, so what will happen is that it will use the out of back score from the previous set of parameters that it has passed. So now we want the minimum estimators. Estimators is nothing but the number of decisions. So we are passing it as 15, and max estimators we are passing it as let's say 100. Okay. So we want a decision tree to be between 15 and 100. So the number of decision trees will be decided based on this. So wherever we get a higher accuracy or lesser OOB error rate, okay. So wherever we get higher OOB score or lesser OOB error, that will be considered. That many trees will be considered for a random forest. Okay, that trees will be there in a random forest. So so now pass error rate in the form of dictionary. So error rate is equal to pass it as a dictionary. So for I range of minimum estimators, max estimators plus one, because this will go till 999. So 99. So we have to pass this 1000. So this will go till 999. So we have to pass maximum status plus one. Now what I'm doing is that, so I'm passing the model that I'm having with random forest dot fit, so dot set params. So I'm setting the parameters of where I'm setting number of estimators is equal to I. Okay. Let's see, set params of number of estimators. The method works. So number of parameters I'm setting is as I. So we have a number of number of parameters, number of estimators as a parameters. So I'm passing it as I. Okay. we have our model, we train our model, dot fit of train set, comma class set. Okay. So now we will get some score from this. Now we will consider only out of bag error. Okay. For calculating out of bag error, have to subtract 1 minus fit random forest, that random forest model dot OOB score. Okay. What I'm doing is that, so now error rate of I is equal to OOB error. Okay. So now let's run this code. So minimum estimators. What's the problem? Estimators. Estimators. Let me run this code again. Estimators. Okay. Wait a second. I'll check. So I ran this code. So let's see. It will take some time. So now this is going to give a set of values. Okay. This error rate of I is going to give set of key value pair where we will get for each number of decision tree what will be the OOB error it will give. So we have to consider the OOB error where it is stable and also where it is less. Okay. OOB error should be less. So those values we have to consider. So wherever number of decision tree is higher with OOB error less, then that is, and also your model is stable in that region during that number of trees, then you can consider that for your model building as the number of decision trees you want for your random forest. Okay. So this is how we have to uh, decide the number of decision tree for your random forest building. So it will take some time. So I have just removed that fit random forest of Homestead is equal to 2 and OVR is equal to 2 for now. So I just passed minimum estimate is 15 and also I'm just checking for number of estimators, which number of estimators will get higher accuracy or higher OOB score after performing the training set and class set validation. Okay, so this will take some time. Hold on. So we will run the code now. We will run this code. So now we have ran this code. So we have got some output. So let's see. Let's check for the output. Before that, what you can do is that. So OOB series. For OOB series variable, I will assign the error rate. So I will create a pt dot series. Pt dot series. Yes, I will create a series for error rate. Error rate. Okay. So now let me plot do the plotting. Figure axis is equal to dlt dot subplots of fixed size. Fixed size is equal to 10 comma 10 comma 6. I will do the plotting now. OOB dot underscore series. So this is capital. So let it be small. Okay. Series. Yes. OOB underscore series. dot plot. Do the let's plot it off. So we want a line plot. Okay, let's plot a line plot, and let's pass it as a color is equal to red. Now let's plot plt.x label. Let's write it as x label is a number of estimators, right? We have number of estimators, and plt dot y label, well, we'll pass it as OB series. Okay, OB error rate. OB error rate is Y label. So, and let's run this code first. Let's see. Okay, name OB series is not defined. So here I change it. Let's run this code again. Okay, I'm getting a value over here. It's 15 point. So I'm getting almost a constant value. So what I'm going to do is that let me take this value to be 500, and let's run this and check how much time it will take. Number of trees have passed between 15 and 500. So let it run, and let's see how much time it will take for this to run. So let me give a title. So while that gets run, let me give a title for our plot as OOB error rate across various forest sizes. Forest sizes is nothing but various number of decision tree for a given forest, for our forest. Okay. So let's see if it's successfully run or not. So it is taking time. It will take time. So we have given 500 days. So this will take some time. So we have got our number of estimators. We have able to run this code. So what we will do is that we will run the other codes as well. So we'll create a series for our error rate first, and then now let's run this. Okay, so it still remains constant. There is some problem with this code, I guess. So what you can do is I will just tell you the other way you can do. So I'm having problem with somewhere over here. So what I will do is that I will take already written code for random forest. So here I will explain from OOB rate. So OOB rate, so for the random forest, we have set parameters of form state is equal to 2 and OOB score is equal to 0. Form state had already told you. So what does form state do is, if I have any particular parameters, like here we have some particular parameters, right? You can reuse previous value and then you add more estimators to that, okay? So false means you can start a new altogether a new tree, altogether new tree. And OB score is equal to 2 means I also want to consider the previous OB score out of bug score that you had got from this, okay? So now let me check with here. So here we have passed number of the decision to be 15 minimum and 1000 as maximum number of decision trees we want. And we have passed error rate, and here we have taken tried to find out the best possible number of decision tree where we get So this will give a set of values in the form of key value pair where we will get OOB error for that many particular number of trees. So we have converted that into a series object, and for we have done the plotting for that. So if you see this plotting, so what we have done is that we have OOB series, we have done the plotting of line plot and red color. So axis horizontal line we have drawn here because here between 0.035 and 0.040 all the data points lie. Okay, most of the data points lie over here. I mean, not data points. It's like error. Error lies in between these regions. Most of the error for a number of decision trees that we pass. So we plot x label, plt dot x label we pass as n number of estimators, and y label we passed as OB error rate. And we have done the plotting for OB error rate across various forest sizes. So forest size is nothing but 15 to 1000 decision trees. How many decision trees? So what you can see here is OB error rate is lying in this region. So where is the error minimum will take? So what we have done is that, so we have taken 600 because at 600 you can see the error is almost stable. So, uh, so from the graph we can choose 400 estimators. So here also it's somewhat stable from between here and here. Or we can, if your processing power is good and don't have time constant, you can go with 600, or you can go with here between 775 and here, okay, 775. But make sure to select the one which is giving stable results. So here it is stable because here the error is less, right? You can say choose 775 as well. Here also you can choose 600 to 625 value. 610, yeah, 625, something value around that. And here also between 400, here to here it is stable. You can choose those values where it's a stable result. So we select the best number of estimators. So we have selected 600 in our case, where it's giving a stable result. And so after you have done the estimators calculation, you can make OOB score false. Before that, let's do something. Okay, so we have OOB series. So for OOB series of 600, we will find out the error, OOB error. At 600, we have an error of around 0.39, okay, 0.03. So you have error of around 33.9 or 4%. Okay. Now we have a random forest. So set parameters for a random forest. Make sure that a number of estimators or number of decision trees is 600. And bootstrap, we will make it as false, true, because we want sampling with replacement, not without replacement, because we have enough data size. And next we have to pass warm state is equal to 2 base false because we don't want the previous value to be used. Okay, warm state is equal to 2. We don't want, we want to build new tree altogether. Okay, and we passed OB score is equal to false as well. We don't want the previous OB score. Okay, so we have built our model. So now let's evaluate our model. Okay, so for that we have to train our model once again with the given set of parameters over here. So we have this given set of parameters and we will train our model with training set, training data set. So we have done training data set, okay. So you don't have to worry about variable importance for now. So this just done the feature importance. This will select the features from our given data set, which is having high mean. Okay, so let me show the feature with has high mean decrease in impurity. That one it will give. Okay, so it will give in order. So this code is just a Python code. So if you want, you can take a screenshot of that. So we are just trying to find the features that are having high probability of the output or the class prediction or the output data set prediction. Okay, so which has high feature importance. That one we are taking. So we have just a Python program we have written over here. So area worst has highest mean decrease of impurity, and concave point then it is the next. So if you see in a plot, you can see that area worst has highest decrease. So this is how you can consider how many features you want to consider for your model. Okay, so number of features we usually take root n. That is square root of n means so total if you have n features, then we take square root of n for your model. So once that is done, so what you can do is that you can do the prediction for your random. So you have a random forest model over here. Okay, so you have a random forest model, and you have trained your random forest with the training set. So what you can do now, you can just go and do the prediction. Okay, so for prediction, so you will pass the test set. Test set is nothing but the X test set, and so we'll get a set of values that is prediction random forest prediction values. And then you will compare this prediction random forest with the test class set. Okay. So prediction random forest, you will compare it with the test class set. That is, you have done this test class, that is white test. Okay. So you'll get an accuracy score based on, so first before the accuracy, so you have test class set and prediction random forest. What you can do is that plot a heat map for confusion matrix you will take first, and you will pass test class set and prediction random forest. So you will get these values. So true, negative, and true positive. And we have, so this is predicted and which is predicted of one, right? So this is false positive and false negative. So we have got our confusion matrix heat max and less confusion matrix. So this is just nothing but same code we have written here in the form of function, so you don't have to worry. So now we will plot the accuracy score. So you have our model. The dot score, if you do on testing set, test class, test set, and test class set, you will get accuracy. How much is the accuracy? And error rate, if you want, 1 minus accuracy gives error rate. So now if you want to do the area under the curve, if you want to check the area under the curve, you will do the random forest. So random forest dot predict probability of x test you will pass, and only you will take the first column, that is your test output column. Output column is the class set, test class set column. So I mean that is prediction. Okay. So then you will plot. Then you will find out the false positivity rate to positive rate using ROC curve. So you'll pass the test class set and prediction probability, and then you'll get false positive rate to positive rate. So you'll draw area under the curve for false positive and true positive rate by plotting, created a plot of false positive comma true positive, and you can label area under the curve is equal to this. You can pass it false positive comma true positive. You could see that we have 98.5% accuracy. So there is 98.5% accuracy, so which says the model that we have built is a good model. So this is an easy method to go with. This is a bit lot of code we have written. The same area under the curve we have written a lot of code over here. You don't have to worry about this. Just follow this set of code, and you will get the same answer. It is just like same. Okay, here. So this will go from here till here. Just same like the previous code that you have seen. Okay. So for building classification, so just pass test class set and prediction values, random forest that you got prediction random forest, or here you got prediction random forest. So you get the value of precision to be 95% and equal to be 97%. This is a good value actually. So once again, we have done the classification report in different way. Once again, so you don't have to worry about this. Just you need this thing. This is enough. You don't have to define a function and do. Now, what you can do is that, so we can predict complete data set. So in our without target data set, we have taken the breast cancer data frame and we have removed the diagnosis column from that. So this is our data set without diagnosis column. And with target data set, we have only taken the column that the value that is diagnosis, and we have flattened our array into one dimension. So this is how it looks. So now we have to do the predictions, right? So we have our model. So dot predict of we have to pass do the prediction for without target data set. Okay. So you will get prediction data sets for that. So once you get the prediction data set, so we'll use NumPy now. So np.where with target data set is equal to prediction data set. Okay. If it is true, then we'll have prediction data sets. If it is false, then we will replace the value with target data set. Okay. So once the prediction data set is done, so we will replace our values 1 by 2 and 0 by false. Okay. So we have done the prediction. So predict data set, we have included some new column. So in that we are using np.where we have done. So we have our the target data set, prediction data set, and target data set compared, and we have got a new column with values zeros and ones. Now we have your data frame. There we have to replace is equal to one, which value to replace is equal to one, and value to replace is two. One replaced by two, and data from dot to replace, sorry, data from the replace dot of to replace. The value is false. And in place is true means we want this operation to be performed in the current data frame. So now if you print that head, you'll see that we have a new column called predict data. This is the predict data new column that we have now. And what you can do is here, so for the data frame of diagnosis, right, you have done some manipulation operation like label encoding. Sorry, map, you have map function you perform. So this replace data frame of diagnosis dot replace of to replace is one. So one you replace it by value is equal to malignant, and in place is two, you want this operation to be performed in the current data frame. And the dot replace of to replace is equal to zero, and value is b benign. So in places two, you want this to be happening in the current data. And just this is nothing but you have created a data frame and you have transferred it to a CSV file. Okay. So this is all about the random forest. Hope you understood everything that I taught in the random forest classification. So I will be coming up with a new set of videos in the next session. Thank you for attending the session.